making y'all talk. Okay, I know we probably went over some of these like a week ago, but we're going to start over just to make sure, because first thing we went through with the cardiovascular system was blood. So about 25, 26, 27-ish task cards are just about the blood. And then it'll go to heart, and then it will ask questions about blood vessels because we split them up into 3 different PowerPoints. So talking about blood first. Name the 3 formed elements found in whole blood and use the scientific terms. Sorry. Erythrocytes. And if I need to spell something, ask me. I had to spell a lot for first period. Erythrocytes are what, though? They're red blood cells. Next. Leukocytes are white blood cells. Thrombocytes are platelets. Good. Erythrocytes, leukocytes, thrombocytes. They're formed elements because they have a shape. They hold a specific shape. What's the 4th component of blood, but it does not have a form? It's not a formed shape. Plasma, yeah. Okay, so out of those formed elements, which one is used to determine the hematocrit? Erythrocytes. So the hematocrit is looking at the levels of red blood cells. If somebody is oxygen levels have dropped, they will usually look at a hematocrit to see if they have enough red blood cells, like a normal level, percentage wise. Number 3, looking at the test tube. If you put blood in a test tube and spin it around really fast for a few minutes, all of the components of blood separates. The heavier elements will go to the bottom. The lighter, less dense will go to the top. What is number 3? Those are erythrocytes. Number 2 is a very skinny, thin layer. I'm going to skip it for a second. What is number 1? 1 is the majority of your blood. Plasma, yeah. So what does that leave for number 2? Your platelets and your white blood cells together make up number 2, and that is considered the Buffy coat. The Buffy coat is the leukocytes and thrombocytes together. That very thin layer right there in the middle. Number 4, it says blood plasma is primarily made of water, but other than water, what else is in plasma? What would you find floating in your blood? Some nutrients, proteins. Say it. Hormones, yes. Hormones, proteins, nutrients. What's the opposite of nutrients? Waste. Yeah, your cells have to get rid of waste. What is one form of waste that your cells get rid of? You exhale it. Carbon dioxide is going to be in the plasma. Salts, minerals, medicine, chemicals, drugs that you're taking, that goes in the blood. Anything other than oxygen. Oxygen is not in the plasma per se. It has to be attached to the red blood cell. So plasma is carrying everything else. All right, what are 3 different ways that a red blood cell, an erythrocyte, its shape gives it its function?
The shape allows it to pass through easily.
What is the shape? Well, hang on, let's back up. There's 3 different types. So the shape that lets it pass through easily. It's round, yeah. So being round allows it to pass through the blood vessels and flow through the blood vessels easy. It doesn't stab into the walls of the inside of your blood vessels, thank goodness. I heard her say biconcave. That is another one. So being biconcave, what does that help for its function? It increases surface area so it can carry more oxygen. By being biconcave, caving in on both sides, increases the surface area so it can carry more oxygen. Marilyn?
It doesn't have a nucleus.
Okay, what does that help?
It doesn't use the oxygen that it carries.
Yeah, it does not have a nucleus of its own. So that means it's not using any of the oxygen it's going to carry. It doesn't have a nucleus, and a lot of organelles. It's missing organelles as well. So it doesn't use any of the oxygen that it has to carry. Number 6. Why can't oxygen travel through the blood on its own?
It's like hydrophobic.
It is hydrophobic because it is nonpolar. Yes, it hates water. Oxygen is nonpolar. Plasma, since it is majority water, it is polar. So being nonpolar, it does not want anything to do with water at all. So it's not going to just be floating around the plasma on its own. It literally has to have something to pull and hold on to it, and that's what's on the red blood cell. These task cards are on Google Classroom if you need to look at them later as well, the questions. All right, number 7 can be a little tricky. There's multiple questions I want to ask in just this one question. So let's start with what it says. How many oxygen molecules can one hemoglobin protein carry? 1. 1 hemoglobin, 1 oxygen. How many hemoglobin are on 1 red blood cell? 4. 4 hemoglobins are on 1 red blood cell. So how many oxygens can 1 red blood cell carry? 4. 1 oxygen per hemoglobin, 4 per red blood cell. So 4 oxygens per red blood cell. And if you get tired of writing erythrocyte or red blood cell, you can abbreviate RBC is red blood cell and WBC is white blood cell, as long as you remember what they are. But that's a quick way to abbreviate your notes. RBC, red blood cell, WBC, white blood cell. Okay, so the hemoglobin protein, it is a protein that's on the red blood cell. It has these hemigroups that are like an element that is holding the protein together, because this protein looks like little ribbon folds and spirals. It has an element that's holding it together, but it also, that element acts as kind of like a magnet to pull the oxygen and stick the oxygen to it. What is the element in the middle of the hemigroups on hemoglobin? It is iron. Iron. Iron is what actually is attracting the oxygen to the hemoglobin. If you are low in iron, you are usually very dizzy and lightheaded and sometimes sick because you're not carrying enough oxygen to your body cells. So it's because you don't have enough iron to make these proteins. What else does hemoglobin do for the red blood cell? Yeah, it gives it its color. The hemoglobin protein is what gives the erythrocyte its red color. The protein does not. All right, what is the function an overall function of a leukocyte? Yeah, fight infection. So it's protecting the body from foreign invaders, or fights infection. That's what they do. They all have a specific job, but overall they're all helping to fight infection. Or anything foreign in the body. Number 10, it does say name 4, but I want us to name all of the ways. I think there's 6 ways that erythrocytes differ from leukocytes. So, what is one way an erythrocyte and a leukocyte are different from one another?
Erythrocytes are bigger. No, leukocytes are bigger.
Why would leukocytes be bigger? What do they have inside of their cell?
A nucleus.
Yes. So leukocytes have a nucleus that makes them a lot larger than erythrocytes without a nucleus. Leukocytes are a lot larger.
What blood cells can leave the thing?
I want to wait, and that one's going to be last because it leads us into the next question, but I will come back to you on that last one. That is true. What else is a big difference? Think about numbers.
There are more erythrocytes.
There are more erythrocytes. What's the ratio? 1,000 to 1. Erythrocytes outnumber leukocytes 1,000 to 1. We have 1,000 red blood cells for every 1 leukocyte we have.
Black blood cells do.
That's another thing that we can compare is their lifespan. How long does an erythrocyte live? It's about 100 to 120 days. It's about 100 to 120 days is how long an erythrocyte's going to live. What about the lifespan of a leukocyte? It could be years. It could also be days. So it depends on if your body's using it. It could be days to years of how long your leukocytes could survive. If you have an infection, they're going to die within days because they do their job and die. But if you don't need them, they can live for years. All right, last one, Mary Ellen. What was it again?
The leukocytes can leave the blood vessels and go to the other parts of the body.
Yes. Leukocytes can leave the blood vessels and go to surrounding body tissues. Erythrocytes cannot. They have to stay in the blood vessel. So I told you it leads us into the next question. What do you think diapedesis is? The ability for a leukocyte to leave the blood vessel. The ability for the leukocyte to leave the blood vessel. Sorry, Miss Hambry is texting me. Okay. Last one. So these are, number 12, are types of leukocytes, but leukocytes can get grouped into these two categories. They are either granulocytes or agranulocytes. What would you expect to find inside of the cell if it was the granulocyte? Part of its name. Granules. Granules are like tiny little nerd candies, it looks like, inside of the cell. You'll see little spots. Some leukocytes release those and it causes inflammation. So granules. Granulocytes have granules. Do you think agranulocytes do? No, anything with A before it means without whatever follows. So agranulocytes do not have granules. That's one difference. The next difference are their nuclei. Some nuclei are perfectly round and we call them spherical. Some are lobed and it looks like they're kind of attached on a string like that. And then some are really big, but they have just a slight curve and they look like a kidney or a liver shape. We call it kidney shaped. So, what type of nucleus would you expect to see in granulocytes? There has to be room for granules. Lobed, spherical, or kidney? Lobed. Granulocytes have lobed nuclei. That allows them to have room for their granules. Agranulocytes have spherical and kidney shaped. They don't have granules. They don't need room for them. So the spherical and kidney shape take up majority of the inside of the cell, take up most of the space. Still talking about leukocytes. We need to know the order of the 5 types of leukocytes from the highest concentration, meaning we have the most of this kind of leukocyte, all the way down to the lowest concentration. What do we not have as much of? What was the saying I told you to remember? It was about monkeys. Never let monkeys eat bananas. All right, so never let monkeys eat bananas. So let's put a name to all of those in order. So highest concentration with an N is what? Neutrophils. Neutrophils is Neutrophils. Those are neutrophils. L. Lymphocyte. Lymphocyte is Lympho, site, CYTE. Lymphocytes. Then monocyte, MONO, site. The next one is spelled differently than you would pronounce it. If you read it the way it's spelled, it is eosinophil, but you pronounce it eosinophil. So E is EOSINO phil. Eosinophil. And the last one, with a B is basophils. BASOPHIL. So the ones that end in phil are those granulocytes or agranulocytes. So neutrophil, eosinophil, and basophil. Those are granulocytes. They have granules. The ones that end in cyte, lymphocyte, and monocyte is an agranulocyte. Those are agranulocytes. You will not have to know the specific job that each of them do unless there is a question on a task card. about a particular kind. All right, next we're getting into our prefixes and suffixes that we need to know and understand in order to answer this. So 14, blood cells are formed by what process? What suffix, the end of the word, means production of? Starts with a P. Poesis. Poesis is production of. What is the the prefix for blood? Hema. And we add a TO in the middle. So it is called hematopoiesis. Hematopoiesis is the production of blood. HEMO, it might be A, TOPOIESIS. Hematopoiesis. Poiesis. Where does that occur? Which bone marrow? Somebody over here. They're not answering for me. What bone marrow? Red. Red bone marrow. Where is red bone marrow found? Where do we find it? Come on, wake up. Anybody? Anybody over here? Teachers? Guys? Haley? Red bone marrow from the skeletal system? Where in the bone? That is correct. Where in the bone? The middle or the end? On the end. Yeah, red bone marrow is found on the ends of your long bones and the spongy bone. You don't have to know that for this test, just a review from what we've done. So it is found in your red bone marrow. The next prefix and suffix that we need to know. So a stem cell. A stem cell is something that differentiates. That just means it starts as one kind of a cell that's immature, and it can mature into a neutrophil, lymphocyte, monocyte, eosinophil, basophil, or an erythrocyte. It could turn into any type of blood cell. So it is right now immature. What is the suffix for immature? We use them a lot in the skeletal system when we talked about building bone. What was the suffix? Osteoblast is the suffix. So blast is immature. Okay. So the end of this stem cell is going to be a blast. What is blood again? Hema, and then cell. Cyto. Yeah, cyto or cyto. So it is a hemocytoblast is the name of the stem cell. Hemo, sorry, it is hemocyto on this one. HEMOCYTO blast. Hemocytoblast is an immature blood cell. Next question you had on your virtual day assignment, I'm pretty sure. So it says immature erythrocytes have huge numbers of ribosomes. Remember, ribosomes make proteins inside the cell. So it is an immature erythrocyte. That means it is not carrying oxygen yet. It is immature. It's still growing. It has a nucleus right now if it's immature. Nucleus has to die before oxygen can be carried. So it has a lot of ribosomes. What protein do you think those ribosomes are manufacturing? What are they making? What's most important? What's the protein that's important? Hemoglobin. Yeah. So these proteins, or the protein that's being made is hemoglobin. So that eventually that erythrocyte can be mature and it can carry oxygen. It needs hemoglobin to do that. Now it's a hormone. So describe what happens while oxygen levels drop in the blood. There's a hormone that gets released if oxygen levels drop too much inside of the blood. Anybody have their notes out or anything? What's the hormone that gets released if oxygen levels drop? Mm-hmm. It does start with an E. Mm-mm. That's a good guess. That's for adrenaline. That has nothing to do with your blood cells. It's not one from the endocrine system. It is, we've only talked about it from here. It is released from the kidney and the liver, produced in the kidney and the liver, released from them. It does start with an E. Erythropoietin. Erythropoietin is the hormone that gets released if oxygen levels drop too low. Kidney and liver release erythropoietin. I think it's Erythropoietin. I believe is how it's spelled. Erythropoietin. So it has the prefix erythro. What do you think that refers to? Red blood cells. Okay, because it's oxygen. Oxygen is carried on these red blood cells. What do you think that hormone stimulates? Doesn't necessarily give it the color. Production of a red blood cell. So what is it going to talk to tell it to make more red blood cells? The heart doesn't make blood cells. The what bone marrow? Red bone marrow. Yeah. So kidney and liver release erythropoietin. That hormone will tell the red bone marrow to make more red blood cells. So when more red blood cells are made, then you can carry oxygen and your oxygen levels raise back up. Kidney and liver release erythropoietin. Erythropoietin will stimulate the red bone marrow to make more red blood cells, to make more erythrocytes. All right, number 18. We do not pronounce it the way that it's spelled. I think probably because somewhere along the lines it was hard to say and somebody got lazy. But it is called a sphygmometer. Sphygmometer. You used one in the lab. What does a sphygmometer measure? Blood pressure. That is a blood pressure cuff. A sphygmometer is a blood pressure cuff. You also had to use a stethoscope to be able to hear it. But a sphygmometer is measuring blood pressure. All right, also from your lab, we looked and you could choose two different arteries to, what am I trying to say? To take your pulse, to count your pulse, your heart rate. So where are they and what are they called? Yep, your radial artery and carotid artery. Where's the radial artery? In your wrist, right above the radius, that bone. Radial artery is in the wrist. Carotid is in your neck. Carotid artery getting blocked causes strokes to happen. Carotid is Carotid. You do have a picture of all of the common arteries and veins on the back side of your blood vessel note page. We don't get into them for this class, but if you do take a higher level anatomy in college, you have to learn every single name of those. I've had to do that before. I just do not remember a lot of them. I remember the main common ones, which actually is a lot less than what your note page has. But the radial artery, you can see where it's coming from. And then the carotid artery comes directly off of the aorta. So you could look at it All right. 20. Blood types were confusing my first and second period just a little bit. So, and I do agree that this question is kind of worded weird. It was just hard to word it. So, an individual that has type A blood would expect to find the A blank on the erythrocyte. What would be found on the red blood cell? What is it called? It is a protein, but we call it something other than protein. It starts with an A. Antigen, yes. So you would find the antigen on the red blood cell, RBC. And if you had type A blood, you would find the A antigen on the red blood cell. That's what you would find. What would you find in the plasma? Not an antigen. It does tell you anti-B. It's called an antibody. And what letter would it be? Again, it gives it to you. Whatever you do not have would be in your plasma. So this gives you your blood type. If you have the antigen A, you have type A blood. What can you not come in contact with? B. So you have the antibody for B. So that means if you ever come in contact with B, the antibody will surround it and clot the blood. So you cannot have B. You have antibody B. Yes. They don't reverse it quickly. They don't drain your blood. All right. If you have B type blood, what antigen would you find on the red blood cell? It's B. Right? What antibody would you find? A. If you have type AB blood, what antigen would you have? A and B. Those are two antigens you would have. Would you have any antibodies? No, none. If you have type O blood, do you have an antigen? No. What antibody would you have? Both of them, right? Okay. So antigens are on the red blood cell. Antibodies are in the plasma. You have the type blood for the antigen that you were given. Oh, we're going to finish a little early. 21, and then I'll come back to 22. I'll go to the board and ask you again. 21, what does hyper mean? The prefix hyper. Too much or high is usually what it will mean. Either too much or something is too high. If it's tension, causes a problem. It does cause a problem, but what is hypertension referring to? High blood pressure. Tension is pressure. So high pressure is high blood pressure. Why is it extremely important for if somebody that has hypertension, they need to get put on medication? Why can they not just live with hypertension? Say it again. Possibly have a stroke, but what is happening? Like, what would their heart be doing if they had hypertension? Beating really fast. It's working a lot harder. So their heart works a lot harder if they have hypertension. What would you expect to see in the blood vessels? Maybe not. It's being really strained. And if they live with hypertension and your heart is having to work extra and your blood vessels have so much pressure that they're being strained, it could completely rupture a blood vessel to where it just splits in half. Or it could be that it just wears out your heart and it will start to kill some of the cells inside of it. So we don't want that either. What? Okay. Yeah, 22 is what we're going to finish on today, and then we'll pick back up with 23 tomorrow in class. None of my other classes got to 23, so I'm going to stop y'all too for the recording. What blood type, and you can look on the board, which blood type is the universal donor? O negative, yes, O neg. Which one is the universal recipient? AB positive. AB positive. When it comes to positive and negative, it's the RH factor. You either have it or you don't. If you have it, you have positive blood. If you do not have it, you have negative blood. Think of it as the glitter if you need to. Can somebody with positive blood be given positive blood? Yes. Can they be given negative blood? Yes. Can somebody that has negative blood be given negative? Yes. Can they be given positive? No. So that is why AB positive can receive everything. They have the A, they have the B, and they have the positive. O neg can only receive O neg, but it can give to everybody because it doesn't have A or B or the RH. It doesn't have literally anything. So at O neg is what blood banks will want. Any questions before I turn this off? Your test is Thursday. Oh, let me tell you about your test. It is 27 questions, multiple choice. You have 7 matching. You have 1 diagram that you are having to label. And you have 5 short answers. I think I probably already told this class that, but just wanted it on the recording. 5 short answers.